Okay. So that is that one. So you sent over 13. We did do 13 yesterday. Do you need me to redo it, or I think we did
No,
13 yesterday.
I
Well,
I I didn't I thought we did 12.
okay, let's do 13 then here. So the arc length here, it's a formula. So you have to first take the derivative of this given thing. And sometimes it's good to kind of rewrite it just to reestablish, like what am I even taking the derivative of here? It is power rule. It becomes y cubed. You bring the 4 down, cancels the 1/4. This one becomes minus 1 over 4 y to the minus 3 power, like that. Okay.
Okay.
And this is where it gets a little bit dicey because then you square the derivative. But your calculator, sorry, this should be positive 3 now. Your calculator will basically handle most of this, I believe. So we don't have to actually expand this. If you did, that would be rough. So the arc length is the integral from 1 to 3. The reason it's 1 to 3 is it tells you it's 1 to 3. Like, just use the numbers that are given. It's the square root of 1 plus the derivative squared. So basically this right in here. And we're really hoping here that this works out nicely. So give this a try in your calculator. Should work out nice, but if not, we'll do it by hand.
Okay.
I'm going to do the same thing here. I'm going to it does appear to work out nicely.
Sorry, I'm writing it in.
And just be careful with your parentheses. You may need to use that math enter to get it to go to fraction.
I got 181 over 9.
181 over 9.
Yeah.
Yes, that is correct.
Cool.
So if you don't get a nice answer, you probably took the derivative wrong, or you didn't put it in,
Mhm.
proper parentheses or something like that, because these are designed to work out nicely,
Okay.
especially when they say, enter a simplified fraction and all that. All right, so here's 15. Says to evaluate the integral. This is like the one we were doing with the 1 over x. Um,
Mhm.
Again, like if you have multiple choice, you probably just put this in your calculator and compare to the answers, but this one does not. Make sure you put the denominator in parentheses. So this is actually a U substitution problem
Okay.
for the bottom here, and we haven't done these in a while, but du is 7 dx, and then you solve for dx. So dx is du over 7. So this is the integral 7 over u, and then instead of dx, it's du over 7. Look at that, isn't that nice how it cancels out there?
Uh-huh.
And then you have the choice here. You have the choice to either change the bounds by putting them into this original, so like finding u of 0 and then u of -1. I would definitely recommend doing that. So that's -2 for the top. Negative 1 is -9. It just makes it simpler to evaluate when you're all done. So this becomes the integral from -9 to -2, 1 over u to u, which is the natural log absolute value of u, evaluated from -9 to 2, natural log absolute value minus 2, minus natural log absolute value minus 9, natural log of 2, minus the natural log of 9. And then if you want to be that A plus student, you put the difference becomes a quotient, and this is your final answer.
Okay.
Sorry about that. Any questions before we move on to the next problem here?
No, I'm okay right now.
Okay. Okay, so if you recall the U substitution problems, the way you figure out what the U is, it's typically the bottom or in parentheses or exponent or something. But whatever it is,
Mm-hmm.
when you take the derivative, 5y to the fourth here, the derivative should be in there in the integral. That's kind of your check. Sorry about that. Big finger needs to be off. That's your check. Like, did I do it right or am I on the right track? And that helps you because it's supposed to cancel out. Right. So then we go back to the integral.
Mm-hmm.
And we always substitute in for u and the dy, or
Okay.
whatever was the u. So we don't have anything for the 5y to the fourth yet over u, but the dy is du over 5y to the fourth. And look at that. Yet again, it cancels out to just the integral of 1 over u du, which is the natural log absolute value of u plus c. So the reason it's plus c this time is that there's no bounds. Okay, so in all the previous problems we had bounds, bounds, so on. So when there's no bounds, it's considered an indefinite integral and there's a plus c. You'll see that in the multiple choice. Now you might think we're done, but you do have to back substitute your u because your integral is not in terms of u. So this is natural log absolute value y to the fifth minus 2 plus c. And yes, you do need that absolute value. So make sure you get that in there when you. Right.
So
Like
I'm
I said,
taking the derivative before everything with these, or using U substitution, and then I can put it in the calculator.
no, these cannot be put in the
Okay,
calculator.
yeah, I didn't think so. I just wanted to
Now,
make sure.
okay, kind of like your answers you can take the derivative of and see if they're this.
Okay.
That's the shortcut here.
Mm-hmm.
So some combination, right? Like some calculators, some not. Anything with bounds, you go to your calculator typically on.
Okay.
Okay, let's go and look at another here. I missed 17. Up there's 17. We'll do 17 next. All right. So this one, if it was on the exam, you'd do calculator, but since it's not, it's a U substitution problem.
Okay.
Your U is this x over 3 or 1/3 x. So du is 1/3 dx. dx is 3 times du. So it becomes the integral e to the u 3 du. And then this one, I don't know that I would I don't know that I would change the bounds, because when you put natural log of 27 in here, it doesn't really reduce. I mean, it does, but it doesn't. It's like, eh. Um, so I'd probably just go back to keeping, I don't know. Could go either way on that.
Okay.
Uh, let's do it. So u of natural log of 27 is 1/3 natural log of 27, which doesn't look like it simplifies, but 27 is 3 to the power of 3. That 3 actually comes out in front and cancels, so it becomes the natural log of 3, which actually is nice. When we do the same thing for natural log of 8, it's 1/3 natural log of 8. 8 is really 2 to the power of 3. That 3 comes out in front to cancel with the 1/3. Those are properties of logarithms you probably learned in a previous course. Yeah, none of this really matters because you're going to go right to the calculator anyway, but that is what it is. This 3 you can just kind of put out in front or in front of the e. If you recall, the integral of e to the x dx is e to the x. So this is 3 e to the u, natural log of 2, natural log of 3. And then you end up putting these in. So 3e to the natural log of 3 minus 3e to the natural log of 2. E to the natural log of x cancels. So whatever's inside the natural log is what this becomes. This becomes 3 times 3 minus 3 times 2, 9 minus 6, which equals 3. I bet if you'd put this in your calculator, it would have given you 3, or it might have given you like 2.99999 or 3.00001.
Yeah, and since it's multiple choice on the test, it
Yeah. So, I mean, just correct your calculator. Don't
yeah, don't hand do it if you don't have to.
if you don't have to. So, all right. So 18, and then some of them didn't come with question numbers, so might need your help.
Okay.
But
I tried to include them all. Sorry.
yeah, no,
Sometimes it
it
happens.
just there's sort of an order here. Okay. And we're good. Like we've been doing them kind of the way you want to do them here.
Yes.
Okay. All right. So this one here. I'm looking ahead. I don't like what I see. So this one looks harder than it actually is.
Okay.
It's called a separation of variables differential equation, which you don't care about. You don't ever need to know. But the idea is that the x stuff is on the right and the y stuff is on the left. And so you're supposed to take this whole thing and rewrite it as integral dy 4 plus 1 over x dx. And that's the separation. The y is on the left, the x is on the right. It's already separated. Um, think of a breakup, my stuff, your stuff, or your stuff, my stuff. And now you integrate both sides. So on the left, the integral dy is y. On the right, it's power rule for the 4x plus natural log absolute value of x plus c. Now you might say, well, shouldn't there be a plus c on the left? And you would be correct. There's a plus c on the right. They get combined. You just have one c, one constant of integration. Now how would you do this on the actual test? Once we get the final answer here, when we're going to take into account this, you would just take a derivative and see which one gets you back to this. So you're really going to do more of what you've been doing earlier in the course here, not
Okay.
so much integration. Now, to get the constant of integration, you're given what's called an initial condition, because there's really what's called a family of curves, and you need to know which one it is. So the initial condition tells you that, this is x, this is y, 7 equals 4 times 1 plus natural log absolute value of 1 plus c. Natural log of 1 is 0, 4 times 1 is 4, 4 plus 0 is 4. So you end up getting C equals 3, and that goes back into this line right here. So your final answer is 4x plus natural log absolute value of x plus 3. And like I said, you just take a derivative of this. Derivative of 4x is 4, check. Natural log of x is 1 over x, derivative of constant is 0, and you have it. This is way beyond the scope of your course, but it is what you have in front of you. Is this 20? 19? Is this 19?
This, I think this one's 20, which is okay.
All right, let me just go. Oh, there's 19.
I
Okay.
know.
This is awful. Okay. Yeah, we'll do this one, then we'll go to, I got 19 up. Yeah, so the lot going on here. The left side here, we written as 5 square root of x times the square root of y, dy dx equals 2. And then you want to move anything that's not y to the other side. So you do that by dividing both sides by 5 square root of x. So you have square root of y, dy dx equals 2/5. Maybe you go like this, x to the minus 1/2 power, kind of up to you. And then you separate the dy dx, like dy is on the left, dx is on the right, separation of variables, your stuff, my stuff, or, whatever analogy you want to make. Y to the 1/2 dy equals 2/5 x to the minus 1/2 dx. And so in the previous problem, when you integrated, it was just dy. The integral dy is y. Here you actually have to do the y integration, which it's just power rule, but it's just another little thing to do. This one's a little bit harder. Like you can't just take the derivative of all the answers to see if you get this. So you can, but you can't. It's like you'd have to manipulate it a little bit. So, um, I'd just throw that out there as a possible stumbling block here. This is x to the 1/2, 4/5. That's simplified, by the way. You can check that later if you want. So because like before, you just had y equals, and you could take a derivative and see if you got this, which you don't have. So they also do not give you an initial condition. So your answers will all have a plus c in it. So to solve for y, you multiply everything by the 3/2 power, or I'm sorry, by 3/2. So you get y to the 3/2 equals 3/2, 4/5 x to the 1/2 plus c. Now, when you multiply in, you get 6/5 x to the 1/2, but the plus c ends up just staying as a c. So like even if you multiply it by a c, it stays c. There's more explanation needed for that, but we don't have. You really, I mean, it doesn't really matter. But last thing is here is to undo the 3/2 power. So you raise everything to the 2/3 power, like that. That's your final answer.
Okay.
So let's just say this was the answer. Like, how would you even begin to like get back to this? That's the thing. That's where you're gonna really struggle. Like, we could spend the rest of the lesson like trying to explain that. It's gonna be hard. So, but would you get this on the test? Probably not. You're probably gonna get like one at this one. So you're
Okay.
probably okay. Like they tend to not give you the harder ones, but
Yeah,
you,
I noticed that.
yeah. So maybe doesn't matter. Okay, 19.
Yes.
Great.
I've never had anything like this on a test, but I don't know.
Yeah, they don't know what they're doing. So check whether each of the following functions is a solution to the differential equation. Okay, so for A, we're gonna do A first. Um, wait, what is? Could you tell me what's under this?
Oh, yes. It's 2y prime, 5y, and 2y prime plus 5y.
Like multiplied together or is there a plus?
The 2y, I'm sorry, I don't know why that's there. Those aren't multiplied together. There's like a comma in between.
Oh, sorry, I know what it's asking for here. All right, sorry. Believe it or not, like just having like a little bit makes it okay. So what they want you to do for part A, this is all referring to this one up here, is they're saying figure out what is y prime. So y is minus e to the minus x. And then 2y prime is just multiplying it by 2. So it ends up being minus 2 e to the minus x. So just verify for me that in the drop down, there's a minus 2 e to the minus x.
Uh, to yes, the minus x to e to the negative x.
Okay.
Yes.
All right, good. So that's first one. 5y, it comes from the original here. So it's like saying take the original and multiply it by 5, which is 5e to the minus x. So that should be there.
Okay. Yes, that's there.
The last part here is you just add these two. So it's 3e to the minus x.
Mm-hmm.
And then what you're asking, like, is this the same as this? And it is.
Okay.
Well, actually, that's the next one. It's
Yeah.
down here. So, all right. For P, this is going to be a lot better now. I don't know what they're doing. Okay. So they're giving you y here, and the first one is 2y prime. Actually, let's do the middle one. Let's do the middle one. 5y, 5y,
Okay.
okay? Because that's easy. It's just multiplying this by 5. So it's 5e to the minus x plus 5e to the minus 5 over 2.
Okay. Yeah, okay.
Now, for the 2y prime, we do have to find the derivative. So the derivative is minus e to the minus x minus 5 over 2 e to the minus 5 over 2 x. And then you're multiplying it by 2. So that becomes minus 2 e to the minus x minus 5 e to the minus 5 over 2 x.
Okay. That's the derivative. And then with adding the 2y. Yeah. All right. Yeah, that's there. If you were asking.
And then the last part is you add them up. So you're adding 5e to the minus x plus minus 2e to the minus x. That's 3e to the minus x. And
Okay.
then you got 5e to the minus 5 halves x here, minus 5e to the minus 5 halves x there, so it goes away. So this is everything.
Okay.
There's your answer.
There too.
So that does also work.
Okay.
Now, does it always work? I think we're going to see the exception here, but the last one's really similar to the one we just did. Um, so we'll do the 5y first. That's again 5e to the minus x. You're just multiplying this up here by 5. plus 5 CE to the minus 5 over 2 X. Let me know if that is there.
It is.
Okay. Now the derivative is the same as the previous problem. It's minus e to the minus x plus, with the exception of that c there, like that. And then multiplying it by 2, minus 2e to the minus x, minus 5 ce to the minus 5 over 2x. Hopefully that's there.
Let's see. Yes, it is.
All right, and then when you add them together,
Mhm.
5e to the minus x plus minus 2e to the minus x gives you the 3e to the minus x, which is what we want.
Mhm.
Then you got the 5c minus 5c, they go away. So I was wrong. They do all want.
And then it says it would be yes again because
Yes,
it's
yes again. Yeah.
still, yeah, okay.
Which if you're into patterns and you think the exam will pattern this, you might remember that they all
Yeah.
look like that. Okay, so 21, good news, 21 is kind of like your exam question. With the problem that fortunately you can't just take a derivative of all the answers. You can, but you can't. Like you'd have to do an implicit derivative.
Yeah.
So you'd have to do all implicits. Probably if you were willing to take like a step in the right direction, meaning like separate the variables and integrate, you would probably be able to get it down to 1 or 2.
Mm-hmm.
So that's what I would recommend. Like, um, if you divide both sides by the square root of y, okay, you end up
Mm-hmm.
getting, and then separating the variables, you get integral y to the minus 1/2 dy equals x to the 6th dx, like that. All right.
Okay.
So now let's just integrate the right side. What's the integral of the right side? Can you tell me that?
Um, would it just be should I put it
No, calculator won't have this. Is just power rule. Just power rule.
oh
And this that's
six
what I'm
x
trying to show you. Like
six
like
x
it
to the fifth,
that's
right?
derivative. That's a derivative. Integral's going the other way. You add
Oh,
1 to
adding
the
the c.
exponent.
Oh
Yeah.
yes. You add one to the exponent. Yeah, and then it's 1/7. Yeah.
Okay, so which two answers have that as part of it?
A and D.
Right. So if you're willing to just do a tiny bit, you get there. Now
Mm-hmm.
this one, you got to be careful with how you do it, but it becomes 2y to the 1/2. And now you have your answer. It is absolutely A. Okay, so
Mm-hmm.
you don't, I mean, if, like I've helped other students do the same thing you're doing here. We're just trying to find a way to get through this. But you got to do just a little bit here, and then you're going to be all set.
Okay.
Okay, number, so this is 21, number 22. Solve the differential equation. So kind of like we've been doing here.
Mm-hmm.
Um, if you notice that a couple of answers are the same,
Yeah.
probably go in that direction. Like it's probably B and C, probably. Okay.
Okay.
That's another thing here. So this requires you to be able to separate out what's going on here. So um, this part is probably the most unclear. It's e to the x times e to the minus y. The
Okay.
reason it breaks apart like that is if the bases are the same, you're adding the exponents. You're like, wait, there's a subtraction there. Yeah, you add them. X plus negative y is x minus y. And they're still the 7. But what that does is it allows you to get rid of the y, get it to the other side. Okay. So
Okay.
now when it's a negative on the bottom, it comes up top. So this becomes e to the y dy dx equals 7e to the x.
All right.
Okay. And then we just separate the variables, integral e to the y dy, integral 7e to the x dx.
Okay.
Okay. Now I want you to integrate one side or the other. It doesn't really matter. But that should tell you something when you do this. Like you should be like, oh, that looks good. Maybe that's one of the answers.
Okay. Um, well, the side with the 7 e to the x, it
Mhm.
would be 7 e to the x plus c, right?
So notice that that is C or D,
Okay.
and that's good. And then, so that gets you down to 2
Okay.
on the left, integral e to the y is just itself.
Oh, all right. So it's c.
Yes.
Okay.
And it's just really hard to, like, if you were to take a derivative of this, you just
Mhm.
wouldn't necessarily know that it got back to this, unfortunately.
Okay.
There's yeah, you gotta. I'm trying. I'm not trying to make you like overdo it here. You just gotta do something to get to that.
Yeah.
Okay. 23 kind of got cut off, so I'm gonna go to 24, maybe. Oh boy, 24, maybe 25. If you want to resend 23, if you could resend 23 as like half screen so that
Yeah.
I
Sure.
can see the whole thing. Um, okay, 25. We should do 25 first. I guess we'll do 25 first. N equals 15. Okay. I may have to look this one up. This one's a little bit odd. Um,
Okay.
the trapezoid rule is the way this works is like when you're finding the area under the curve and you're using the trapezoid rule, there you draw this trapezoid here, which may not look like a traditional trapezoid, but trapezoids have one set of parallel sides. And what happens is you end up double counting the the interior ones because you can see like this length here, this middle vertical line, it's used both on the left trapezoid and the right trapezoid.
Mm-hmm.
And so the formula for the trapezoid rule is it's basically f of a plus 2 times f of all the interior ones, 2 times all the interior ones. But then you get to the end and it's just 1 times the end point.
Okay.
Now I want to look this one up because I don't want to, oops, I don't want to give you the wrong answer here. Um, there's probably a practice problem like this that would help. But let me go here and see if I can. All right, a rectangular. And there we go. Okay, so there's a bit more here to doing this. So the first thing is you do have to calculate this delta x, which is what's b minus a over n, 75 minus 0 over 15, which ends up being 5. And then the trapezoid rule um, is this delta x over 2. So uh, that's going to be this 5, and then it's always over 2 times. And then because this number is in here, usually this number is not in here, but they've snuck that one in. Um, you multiply by this, I don't know what to call it, the width. I guess we'll call it the width
Okay.
times, and this is where you're doing the d of 0 plus 2 times d of 15. Now, why 15? Because your jump is by 15 here. No, no. 15. Sorry, there's 15 of those. Sorry, no. That is not right. D of 5. So I need to count this real quick. There should be 15 of these. 1, 2, 3. Yeah, okay, so there is. Um, plus 2 times D of 10, and so on. 2 times D of 70 plus 1 times D of 75. Okay, so this looks really, really complicated. There is a shortcut here. You do have to calculate the delta x. So you calculate delta x, 5 over 2 times the width, 40. And then you add up the numbers in here on the bottom, but you have to double the interior ones and so on. And then for the last one, you just add it in.
Okay.
So the end ones you use singly, the interior ones you have to double, and then you have to do this other multiplication.
Okay.
Okay, so we should both be doing this because the good chance one or both would make a mistake on the calculation. So yeah, I know it's awful, but that is the nature of these things. So
We're putting everything in between too. I just want to make sure.
I do have the answers, so whenever you're available, got yours, we should compare.
Okay. I'm adding all of them, right? I just
Well, it's multiplication. You know, yeah, you double these and then you add them all up and you get some number and you multiply by, you know, this out here. It ends up just being 100, but so if you got an intermediate answer, that's okay too. I'm looking for, see if I can really quickly get one more done for you here. Probably not going to happen on that one. All right,
yeah,
let me look up.
I got 100. I got about 100, yeah, somewhere around there, 90.
Well, no, this part's 100 and this should be like 3225, I believe, or 322. My final answer, and we probably should just go with it and get some more one more question done quickly, is end up getting 32 32,250 is what I
Yeah,
end
I
up
got
getting. So, uh,
30,180. Oh, because I didn't finish adding. That's why I stopped. Okay.
okay. So in the limited time we have here, for this 23, so it tells you that the half-life, and there's a formula for this, that the half-life is natural log of 1/2 over t. It's this k value. It's p equals p0 e to the kt, like that. And we don't know the initial amount, but we'll just call it 100. So your k is natural log of 1/2 over 139. And then we're interested in 80 after 88% rate on the day. Okay, so 88% has to disintegrate, which I guess means you're down to 12, not that. So that might want to look that up real quick. But you end up getting this value for k, e to the kt, and then you solve it for t. T ends up being the natural log of 12 over 100 over k, which is this thing right here.
Okay.
So I know we're short on time. Let me just try to do this calculation for you real quick. Um, see if we get something even reasonable. And all right, natural log 12 over 100, natural log 1/2 over 139. Okay, so I get 425.2 days. And I probably
Yeah.
talk about that later if we need to. All right, I saw you schedule some more lessons. We're gonna do like